I'm going to walk through question 1 on module 4 assignments using a probability tree similar to the one in your book on figure 4.8 to illustrate how we know where our factors go in this equation. The PSA is known to have a high false positive rate. Suppose there is a 0.02 probability that a male patient has prostate cancer before testing. The probability of a false positive test is 0.75, and the probability of a false negative is 0.20. If we say that any random male goes to the doctor and he takes a PSA test and the results come back, there's only 2 possibilities. Really, there could be 3 if we want to get technical because it could be inconclusive. We're going to say there are 2 possibilities. Okay, so you test. That's good. Let's do that. And there's 2 possibilities. And those possibilities are that the test comes back and says he has cancer, or he does not have cancer. That's our 2 possibilities. And we can say that our patient that does have cancer, when he takes his test, he's either going to get a positive reading or a negative reading. Regardless, I mean, he has cancer, but we don't know, is he going to get a positive or a negative? And the same for a patient who does not have cancer. He's either going to get a positive or a negative reading. Okay. The probability of a patient getting a false positive is 0.75. If our patient has cancer and he gets a positive test, it's not a false positive. If our patient who does not have cancer gets a positive test, now we have a false positive. So we know that this value right here is the 0.75. Now again, we can look at this and say 1 minus 0.75 gives us a 0.25 that the patient does not have, or he gets a negative reading. We know that up here we can do the same thing, that if our patient has cancer, and he gets a false negative, he has cancer, he gets a false negative, well, then we know that that value is 0.20, and 0.20, 1 minus 0.20 is 0.80. So my patient with cancer has an 80% probability of getting a test that comes back as saying positive he has cancer. And we know that there's a probability that 0.02 males do have prostate cancer. So here we can say that's the 0.02. 1 minus 0.02 means that there is a 0.98% chance that the patient does not have prostate cancer. And that is exactly how we fill in these numbers. Now, let's put some values or identify these so that we can plug them into equation a lot easier. So we're going to say this is our A1 and this is our A2 for our first equation when we're saying what is the probability of a false positive test. In that, we're going to have A1 and A2. And since we're looking at a false positive, these are our B's. So when we put these numbers in this equation, and we say PA1 PA1 times the probability of a positive reading at A1. So we can say equals 0.02 times 0.80. Okay, and then for our bottom equation, we're going to repeat that. As you can see right here, we're repeating that. So we say equals 0.2 times 0.80. Plus probability of A2 and the probability of a positive reading for A2. That's right here. So then we're going to say 0.98 times 0.75. And then all we have to do is divide this. And this is supposed to be 4 digits according to the assignment. So let me knock it up to, there we go. So our probability of A1 occurring with I know that figures on that line is on here somewhere. So /B. Here it is. Had dust on it. Couldn't find it. Okay. Equals. Now, we need to reevaluate all of this when we're looking at a false negative. So when we're looking at a false negative, our A1 becomes does not have cancer, and our A2 becomes has cancer. So those are flip-flopped. These are still B negative and B negative that we're working with. So we plug in this equation. I like that pink color. That's fun. And we say that PA2 times PB at A2. So that's our A2. So our numerator is equals 0.02 times 0.20. And just to be clear, the reason that these flipped is because in the first equation, we were looking at the probability of a false positive, and now we're looking at the probability of a false negative. And so we had to flip those. So we've got that. And then we want PA1 and B of PA1. So we say equals 0.98 times 0.25 plus, and then we do this one again at the A2 is the 0.02 times 0.20, and then we can divide and so our probability of equals our probability, probability of A2 at B. I didn't want the cell A2. I saw that because that would be really would be an A with a superscript. Oh, let me see if I can fix that for you. Nope, didn't want to let me, so let me delete that. A insert, didn't want me to insert either. It let me there, I guess, because I don't know, I did have something in A1, so I don't know why it won't let me, but that would be a superscript because really I'm solving for these guys over here. So the probability of a false negative is 0.161. I hope that helped. I know that was a really long way to get to the answer, but I wanted you to understand how to get to the answer rather than just plug in some numbers in to a formula that's already been set up for you. So good luck, and we'll see you later.